Bridget, what was the other three? Oh, yeah. What crowd? Yeah, that's
Can I go see if I left something?
Yeah.
no. That was before.
Okay, so I was done yesterday. Yesterday was really easy. And the day before. Well, the day before I was gone for a doctor's appointment, and yesterday I was gone for a kidney check.
Did you want to check the homework? Here's the.
Nope, I'm gonna put it all as one, because there was only a few problems yesterday. Okay, permutations first. Again, you've done permutations and combinations in the past. Permutations are the number of ways to order a set of objects. So this is where order matters. Yesterday we did the fundamental counting principle where we had our event 1 followed by event 2 followed by event 3. Permutations and fundamental counting principle are basically the same thing. If you can do it with one, you can do it with the other one. So it doesn't matter which one you want to use. And when I do these problems, I do them both ways to show you. So that's that. So let's do some examples that are permutations. Maybe we should do combinations with it. Mix them up. Ooh, change my plan.
There it is.
Ooh, mix it up. Let's do that. Oh, no, I better not. I better stick with I'll stick with what I got. Okay. Okay, problems that you're familiar with. We want to line up 6 people for a photo. How many ways are there to do that? This is NPR. Oh yeah, I probably should put that right here. Yep, I'll show you how, refresh your memory on how that works. Okay, well first of all from yesterday, we could do this with the fundamental counting principle, and I'll show you how that works. Well, how many events am I doing if I'm lining up 6 people? 6 events, so they got to pick somebody to be first, somebody to be second. So if I think about fundamental counting principle, it's 6 events. It's the first person in line. How many choices do I have to pick from for the first person? 6. Then I have 5, 4, 3, 2, 1. That is 6 factorial. With the NPR button, N is the number of objects I have, P is placing them in order, and R is how many I'm using out of my N. Well, how many am I using out of my 6? All 6. So this would be a 6P6, because I'm using all 6 of them. So where is that NPR and NCR button at on your calculator? Where is that factorial at? They're all kind of in the same spot. That's under math. And then over to PRB. Or over to, yeah, probability. But you have to have your numbers in there first. So if I wanted 6 factorial, I have to get the 6 first, then go to math, over to PRB, factorial. If I want to use the NPR button, I have to put the N value in first, which is a 6, then go get the NPR, math, over to probability, number 2, and then 6. If it's all 6 of them, all the way down to 1. It's on there. Yeah, I bet it's under there. Yeah. 1 bar.
I know it's on there because I used them last year.
Hard. That's the end of one of these landing ones.
Everything is way more funny. Every little thing.
I don't know where else I'll probably get, let me find it. Okay. Number 2. Yes. N are the total number of objects you have. And R is how many you're going to use, how many you're going to place in order. So the number used. The number of objects used. So we just did one example where we're using all of our objects. Now we're going to do somewhere we're not going to use all of them. Like let's say the, let's go with the softball team. Has, let's say, 15 players on it. And for part A, you are going to vote in, pick a captain and an equipment manager. How many ways are there to pick these two people? So again, I'm going to do it both ways. How many events am I doing? 2. I'm going to pick a captain. I'm going to pick an equipment manager. I'm doing 2 events. So with the counting principle, how many ways are there for me to pick my captain? 15. So I pick a captain. How many ways are there for me to pick my equipment manager? 14. Because the order matters here, how would I do an NPR with this? 15. I've got 15 objects. I'm going to pick or place how many of them? 2. Both of those will give you the same answer. So how many ways are there to pick those 2 positions? 210? Agreed? 210. Both of them come out 210. Do I care which one you do? Absolutely not. How many batting lineups are there? Okay, non-softball people or non-baseball people. How many people are in the batting order? 9. We've got 9 who bat first, who bat second, who bat third, all the way down to the 9th batter. So, yep. So there are 9 batters in a lineup. How many different options does the coach have to create that lineup? 15 P9. When I want to do the fundamental counting principle, how many events am I doing? 9. I got to pick 9. That would be 9 dashes. That would be the long way, but I could. I'm not going to do the whole thing here. 14, dot, dot, dot. What would my 9th one be? I don't even know. 6 or 7? 15, 14, 13, 12, 11, 10, 9, 8, 7. Or, I've got 15 people. I want to place how many of them? 9 of them. 15P9 is going to be the quicker way to do that one. Which is how many? Quite a few, isn't it? I don't know it.
Wow.
Oh.
Wait. Count these out. 1,816,000,000. We'll go 18 Bell.
18 billion?
No,
Sorry, 1,800,000,800.
Geez, that's 1,816,214,400 ways to do that lineup.
They should really put commas in here.
Yeah, they should. I think the newer ones might actually.
Really?
Does anybody have a, or no? I know some of the scientific ones do. Does not, okay.
Do you have the new one?
Yep.
Yeah.
Well, not these. These are
Yeah.
214.
This TIA equipment, I don't have radio.
No, at the end there's 400.
Okay, plus. Not the color one, I used it, it doesn't. Mine's TIA. No, the colorful one, they have it at Staples, but it's like, she said, okay, $40 more.
That's all I get to.
I have really high questions.
Giant. He's like, it's so ridiculous.
They don't count the other one.
It's like,
Not much.
We really don't.
I just like.
I've got that maybe a little bit more than 2. How many distinguishable ways?
Do I have to write the word distinguishable?
Yes, because that's going to be the key here. Arrange. How many distinguishable ways can you arrange the letters in the word I? What does distinguishable mean to you? Distinguishable? What does distinguishable mean to you?
each one has to be very unique.
Unique to the other one, that's a good way to say it. Okay, so, let's think about it. I've got how many objects that I want to order? Let's just see. I'm doing 3 events. I'm going to pick a letter. How many letters do I have to pick from? 3. Then I've got 2. Then I've got 1. So there should be 6 different ways to arrange these 3 letters. But are they all going to be different from each other? Why not? Because the E is the same in there. Let's try to come up, let's call this E sub 1 and this E sub 2. Just so we can see the 3, are the 6 ways to arrange those letters. We could do a tree diagram here. I guess I didn't leave myself enough room. Huh? So, let's list them out. I can squeeze them in here. So we've got E1, Y, E2. That's one way to arrange the letters. Give me another way, an organized way. Let's leave the E1 here and switch these 2 letters. There's 2 ways. Now what should I do? Start with which letter? You know, I'll start with Y next. If I start with Y, then what can I have next? E1, E2. Can I start with Y again and create a new one? By switching the E's. Okay, what letter haven't I started with? E2. Well, we're going to talk about different afterwards. I want all 6, because we figured there's 6 ways to do it, but are they all distinguishable? No, we're going to throw some out here in the end. E1, Y, and the last one is... Okay, now we want distinguishable ones. So forget the little 1s and 2s are there. Which ones look the same? What can I cross out?
The bottom 3?
Let's see, I got an EYE. Here's another EYE, so I'm going to get rid of that one. I got an